Hi, this is Ms. Inman, and we are going to practice some water potential questions. So, if a cell's water potential is 3 bars, pressure potential, and its solute potential is negative 4.5 bars, what's its resulting total water potential? So this just requires you to remember that water potential is equal to solute potential plus pressure potential. Remember, pressure potential is positive because it's the pressure a cell is exerting based on like the cell wall against water coming into the cell. Okay, so since the solute potential is negative 4.5 bars and the pressure potential is 3 bars, then we have negative 1.5 bars. So the result is that the water potential of the cell is negative 1.5 bars. I always find it helpful to include my units and write my answer in a sentence because sometimes you get something and you're like, the water potential of the cell is negative 124 bars. No, that seems really weird. You go back and check your math and find your error. Okay, the cell from question 1 here is placed in a beaker of sugar water with a solute potential of negative 4 bars. In which direction will the net flow of water be? Well, remember the cell's water potential is negative 1.5 bars. And then the water potential of the beaker is going to be equal to the solute potential plus the pressure potential. And remember, a beaker has a pressure potential of 0 in an open beaker. And so this is just going to be negative 4 bars. Okay. And since the beaker is more negative than the cell, water will flow into the beaker because water goes to the more negative water potential. Another way to write this is that the beaker is hypertonic, more stuff in it, to the cell. Water will flow into the beaker. Okay, the next question. The original cell from question 1 is placed into a beaker of sugar water with a solute potential of negative 0.15 megapascals. Okay, and a megapascal is 10 bars, while the solute potential of the beaker is negative 0.15 megapascals, and that is going to be negative 1.5 bars. Okay, and so remember again that the beaker has a pressure potential of 0, just like this one up here. So the solute potential of the beaker will be the same as the water potential of the beaker, negative 1.5 bars. And remember that the water potential of the cell, it goes negative 1.5 bars. And so there will be no net movement of water because the cell and solution are isotonic. Same tonicity. Okay. Number 4, the value for water potential in root tissue is found to be negative 3.3 bars. So the water potential of the root, 3.3 bars. If you take the root tissue and place it in a 0.1 molar solution of sucrose at 20 degrees C in an open beaker, what is the water potential of the solution, and in what direction would the net flow of water be? Well, temperature is 20 degrees C is 293 Kelvin. Okay, and so we want to find the water potential of the solution, which is the solute potential plus the pressure potential. Remember that pressure potential is 0 in an open beaker, so we're just at solute potential. And we use that negative I CRT. You do not need to memorize these equations or any of the constants. I will give them all to you on the exam. But sucrose has an ionization constant of 1. The molarity here is 0.1 molar, which is 0.1 moles per liter. And R is 0.0831 bars per liter per mole Kelvin. oh my gosh, running out of space, times 293 Kelvin. And we like to go through and cross out moles, moles, liters, liters. Yep, we're just left with bars. And this is negative 2.43 bars. So water will flow into the root tissue since root tissue has a lower water potential. Okay, so just there we go. Okay, number 5, sodium chloride dissociates into 2 particles in water, sodium and chlorine. Okay, if the solution in question 4 had 0.1 molar sodium chloride instead of 0.1 molar sucrose, okay, what's going to happen here? So remember that the water potential of the root equals negative 3.3 bars. And the water potential of the solution is solute potential plus pressure potential, which is 0 because this is an open beaker. So we're going to use negative I CRT for the solute potential. Since this is sodium chloride, it's negative 2 times 0.1 moles per liter times 0.0831 bars liter per mole Kelvin times 293 K, because we're at 20 degrees Celsius and we can cross out Kelvin and moles and liters, and we're just left with bars, and it's negative 4.86 bars as the water potential of the solution. And so water is going to flow into the solution. Water will flow into the solution as the solution now has a more negative water potential. Okay, I hope that's helpful. Come back if you need more help on further videos.